Hi, everyone, and welcome to this week. Now, in the last video that you saw, which was a couple years old, I really emphasized the proprietary nature of why the OSI model existed, why exactly the ISO group wanted to, I guess you could say, standardize or explain how two networks can speak with each other, whether they are next to each other, if they are, or whether or not they're in the same campus, or whether they are in completely different autonomous systems or ASs. This is more like a detailed description of each layer of the OSI model. Now, the question is, it's one thing to say or to ask if we have actually heard of the OSI model, or can you explain some of the layers? But the question is, how many people, or what is the thought process of how how it is used, or who actually uses it, or how it is used in this industry? Okay, and that question may not be fully answered in this video, but by the end of this week's content, the hope is that you can actually see, and hopefully I can plant the seeds within you to answer the question how it can possibly be used to to really diagnose the I'm going to say the risk factors of getting a piece of malware infected into your system. And more importantly, we have to assume that it is out there. And every time you literally open up your web browser, there is you do run the risk of getting a piece of malware. Basically, you open up a window. Anytime you open up the window to let the sun in, or let the cool air in, you do run the risk of something infectious coming in. Like, for example, getting together with a bunch of people is a necessity. I mean, we have to be somewhat social, okay? However, you run the risk, don't you, of possibly getting an infection from them. Somebody coughs, or just the very fact that they're in your presence, you might get COVID, something highly contagious. That is a risk. So, is the solution to close yourself off socially and to never expose yourself? No. If you do that, I mean, because quite frankly, we have to talk to people. Like, in case of an emergency, we have to call the police to do our taxes. Sometimes we have to actually, meet our tax guy. If we have kids, they're going to go to school, they're going to come home after they've been exposed. It's inevitable. So the best thing we can do is to not consider locking ourselves up from the world. It is to prepare to defend ourselves against infections in the same way as our layering of our basically of our technology. Okay, so the OSI model really is a blueprint, really, of how data moves. And so, if we can define the blueprint, we can also identify how and where malware can hide. And we'll talk about that in the next video. This is more like just a description of the OSI model in general, a little bit more detailed than the last video, which was essentially a 2-year-old hype video. And I hope you enjoyed it. So, anyways, you're probably not going to enjoy this video as much as the other one. It's going to be a little bit longer, but we're going to start with the top layer, layer 7. That is the most easy layer to really visualize, because it's when you consider the difference between layer 7 and the other layers, it might help to look at what is prior to the layer 7, what is understood, what is kind of like, what is assumed, if you will. Pretext. What is a pretext of a layer 7 situation? Well, before layer 7, and I'm not, so what actually numerically comes from layers, precedes layer 7, layer 6, because 6 is lower than 7. However, when we say before, we have to understand that when we analyze the 7 layers of the OSI model, we're actually doing it from the bottom down. So we're actually doing 7, 6, 5, 4, 3, 2, 1. Layer 7 being the topmost layer, which is what we call the application, and layer 1 being the most bottom layer, which is the physical. So layer 7, so if I asked you what comes before layer 7, technically nothing, because there's only 7 layers. But think of it like this, think of it more visually. If you had a stack of 7 things and you start at 7 and then you go from 7, 6, 5, 4, 7 being the application, 1 being the physical, then technically nothing is on top of that layer 7 because there are only 7 layers. There's no 8th layer. But what if there was? What if there was an 8th layer? Now, to help you understand that when we I guess study the OSI model, we technically start at layer 7, which is application, and then we go from layer 7 to layer 1, not 1 through 7. Let's look at what could come before 7 theoretically. What if there was an 8th layer? What would the 8th layer be? Now, the question is, what constitutes, what actually things are in layer 7? Well, examples of layer 7, and we can define the seventh layer of the seventh layer in the OSI model is what exactly we are doing. What kind of packet or what kind of frame or whatever are we trying to form? And that comes into that comes into fruition with the person, which is, you could easily see, would be the layer 8, the actual person, what they are actually doing. And I'm sorry I keep on using the term actually, using the word actually, but it all is determined by what the user itself is trying to accomplish. So, for example, if they are trying to go to a website, which is the easiest, scenario one could actually see. Okay, think of it. How often you are on the you're on some sort of web page right now viewing this video. Now, this video might be coming through Canvas, right? But it's actually being served via YouTube. Now, how do we access YouTube? Technically, we access YouTube through a plain old web browser. So the web browser goes into YouTube, and what kinds of informations is actually being transferred, and it would be sent HTTP or HTTPS. So HTTP basically is port 80. HTTPS is port 443. And so those are examples of actual protocols that are used to be transferred. So an example of and layer 7, which is the application layer, is HTTP traffic. DNS allows us to resolve domain names to IP addresses, and IP addresses to domain names. Email. If you want to send an email, you're going to use the SMTP, Small Mail Transfer Protocol. And there are APIs. They live on layer 7. Okay. Application programmable interfaces. Okay. Examples. So APIs allow two, I'm going to say, networks to talk to each other without human intervention. Obviously, the human is going to be setting that up, but once it is set up by the human, they can now, APIs, two applications can talk to each other in a language that they understand. Examples of API packets are YAML, JSON packets. Okay, so anyways, layer 7 defines what we're trying to do. Are we trying to send an email? Are we trying to telnet or SSH into a remote server? Now, the easiest thing we can do is to go from layer 7 to layer 6, but to visualize, let's do the extreme. Let's go from layer 7, the application layer, all the way down to layer 1, the physical layer. And the reason why I say that is the physical layer determines how those bits are being transferred physically. Layer 1 is called the physical layer because it defines how those ones and zeros are being shot, or how are being transferred from source to destination. Now, examples of the physical layer including printers. Not I'm not talking about the network printer. I'm talking about the physical printer. Anything humans can actually touch, keyboards, and printers, that would be the physical layer. Another example of the physical layer are, for example, coaxial cables. Another example is Cat5, Cat5e cables, fiber optic cables. So we're talking about the actual cables. We're talking about anything that transfers actual ones and zeros. So on Wi-Fi or wireless, you're talking about RF waves. If you are connecting two routers or two modems via fiber optic cables, that would be light being transferred. If you're talking about Cat5 cables, you're talking about, copper conducting, wattage or voltage. So the actual voltage, being measured on a I almost said coaxial cable, although that's another example. But the voltage being measured in a Cat5 cable as copper is conducting electricity, that's yet another example of the physical layer. Interestingly enough, when it comes to network devices, we're going to talk about the differences between switches and hubs, or we have, if it's appropriate, we may touch on that. A switch is able to forward MAC addresses, because a switch forwards MAC addresses. We call that the layer 2 or data link, and we'll get to that in just a second. And the physical is an example of a physical device, or a device that lives in layer 1 for physical, is the network hub, because a hub is a dumb device. It is not able to interrogate frames and filter them, or forward them based on MAC addresses. It literally, inside a hub, is basically like an extension cord. If you've ever seen, let's see if I have an extension cord here, or one of those things here, and I do actually. So, like, for example, inside a network hub, it might be like one of these three pronged. You can look at every interface is like another prong in here, and if it's plugged in, it'll just take electricity. It will not. If, like, I've seen those plugs that are this on steroids. They have like 8 plugs in, and you can also hook up your cell phones, and I've seen those advertised on my Facebook feed. I want you to go into the comments and take a look. If somebody plugs in, they'll have real certified electricians, and they'll say this is not safe because it promotes the over plugging, and because it may not have regulation software program into it, it's going to begin to send out too much electricity for the level of copper that it is certified for, interiorly certified for, so it is a fire hazard. That's an example of a risk of that you're using a network hub, because there's no filtration. It doesn't know. It's not able to filter by MAC address. It's not able to filter by too many collisions, and you might tear down a network because there's no filtration. So, and there's no intelligence built into a network hub. A network hub will just send out those zeros and ones. Okay, so we went from layer 7 to layer 1. Let's take a look at layer 6. Now, layer 6 is presentation. Now, when we look at presentation, we're looking at format. So you're looking at how will you interface between one node or client and the server, or between two servers. Are you utilizing a certain I'm going to say standard of hashing. Okay. Are you using a certain uh, um, are you using a certain level of encryption? For example, there's a different level of encryption between the Wi-Fi standards of 802.11b versus 802.11n. And yet another standard. There's another standardized encryption that is being used between 802.11ac and 802.11b. What I'm saying is that there's different advantages that the different Wi-Fi spread spectrums have. One a huge advantage is speed. So, for example, from a spread spectrum standpoint, 802.11b was much slower than 802.11g back in the day. But what advantage did now 802.11g came after 802.11b, so it would stand to reason that 802.11g is superior than in every way over 802.11b, except that's not the case. 802.11g, because it was part of a spread spectrum that was more powerful, 802.11g's was able to support high speed internet connections. So you can enjoy video, high speed video on demand. Whereas 802.11b was could be high speed, but not like the G standard. 802.11b at best, you can maybe enjoy an audio podcast, but it was not built for video because video requires so much more bandwidth. So wait a second. If 802.11g came after B and it was faster, G was faster than B, then why would you ever want B? Well, the fact of the matter is B, because it used a slightly different spread spectrum. There's that buzzword again. It was slower than G, that's true, but because the 802.11b spread spectrum was in the lower frequency, when you have lower frequency waves, it could go farther than G. So if distance was ever a consideration, unfortunately, you're stuck with the whatever bandwidth was 802.11b, and that was an issue. So you could actually choose what SSID or service set identifier you were willing to beacon. If you chose distance as your main thing you wanted to deal with your whatever app you're dealing with, if distance was the issue, unfortunately, you would beacon based on B. If video and quality of service and some of these higher end bandwidth concerns like telephony was an issue, then unfortunately you would beacon with 802.11g. However, you'd know that there are distance limitations. And then when 802.11ac came about, that had the advantages with 802. There was 802.11n, which is directly compatible to both A and G, but then there was 802.11ac, and you were forced, in many instances, if you had a very old wireless adapter, you were forced to upgrade to an adapter that could join in 802.11ac. So the point is, the presentation layer defines the format of the request that you are accepting, and the awkwardness comes into play when you say, hey, you have the proper the key, the proper SSID key, but the point is, if you are not using the proper wireless adapter, it is possible that you can supply the proper password or key and still not be able to join because the SSID is only accepting wireless signals that can join an 802.11ac SSID. And if you have a very old adapter, you could give your password, but if it only accepts 802.11a, 802.11b, then you're not going to be able to join. And the original standard was 802. The original improvement was, believe it or not, 802.11, just A as an apple. And if you have the original A, you can't join AC. It's or without tremendous modifications because of the different formats and different protocols involved. Okay, moving from application to presentation, we move then into session. Session just manages connections. Now, in case you got everyone's like, well, wait a second, what is the big deal about managing connections? It determines who automatically gets connected, who never is able to reconnect, and we can also see who connects too much, like who never logs off. Okay, examples of session layer pieces of technology include network printers and also SQL databases, because databases, whether it's SQL, no SQL, whether it is MongoDB or whatever, it is going to have to manage millions of connections all across the world. Imagine, if you will, how many connections an Amazon server is making, yeah, per minute. It's thousands of connections per minute. How many? Imagine how many connections per second, and things like this. Some of you are watching this video and are perusing Amazon for clearance deals and stuff. Some of you may have started a drop shipping service that you connect with Alibaba servers, and from Alibaba you populate your own store. So you're using two servers in conjunction with each other. Anyways, moving down to the transport layer, we have two flavors, if you will, TCP and UDP. We'll talk about that in the next video. The layer three, the network layer. Now, for some reason, when the OSI model was being basically created, you wound up with now the reason why the OSI model does not use sorry about that. There was a little bit of a disruption in the service. The reason why the IP address is not used as an example of the network layer is because the OSI model, the OSI model was coming into fruition, they didn't have IP addresses because the ISO people first started developing the OSI model in the 60s, and they only had Apple Talk and things like that. They never envisioned a world where a person could open up his cell phone and be his in the basement of a home and being able to connect all the way to some server in Iowa, when they go to Amazon website. It just didn't come into fruition. Layer 2, I kind of touched on that prior to this. Layer 2, they supply MAC addresses, okay? And it's actually, there's two sub layers of the data link. There's the logical link controller and the big MAC layer. But right now, we're just going to, because this isn't a Cisco class or anything, we're just introducing OSI just to help you understand the Wireshark output better. And that's the only reason why we're talking about this. All we have to worry about with the layer 2 layer is the MAC address. Layer 1 is the physical layer, and we kind of already touched on that. But again, with layer 2, we're talking about the data link. That's why layer 2 switches can be seen as a layer 2 device, because it is able to filter and forward based on MAC address. If it's in convergence, as well as layer 1. An example of layer 1 is the network hub, because the hub is just a physical device. It's a dumb device because it's just forwarding MAC addresses without being able to filter them. And that, my friends, is a very 1,000-foot view of the OSI model.